Hello everyone, welcome to lecture week. So this is the last lecture week of the calculus class, and in this lecture, we're going to talk about mainly the applications of integration. So let's dive in. So first, let's look at the marginal analysis. So this is something we looked at earlier. We have for example, the Rx, which indicates the revenue of a certain quantity. So if we produce X quantity, we have this revenue, and the derivative, the first derivative represents the marginal revenue, right? Means that if we increase the quantity, increase the production, then how much revenue, additional revenue, we are going to get, right? So if we now take this first derivative and then integrate it, we get and we integrate using a definite integral, we get the revenue or the additional revenue by moving production from A to B. Right? So this is a literal interpretation of the definite integral from within this range. And similarly, we have the cost. When we integrate the marginal cost and when we integrate the marginal profit, right? Similar interpretation. So let's look at the first example. Right. So in this case, we are given the marginal profits, the expression, and we have this range. So the question says that currently it's manufacturing 500 units, and it's planning to increase its production by increasing it to 1,600 units. So what is the change in the monthly profits? Right? So basically, we're asking what is the new profits, right? New profit means X equal to 1,600 minus the old profits, right? The current profit. So basically, we just need to calculate the expression, and how to get that. Utilize this this one. So we can just integrate it first, and then calculate the evaluations at these 2 points. So these 2 points, and then calculate the difference. So this is how we can calculate the results. All right, and let's look at the income distribution. So we want to focus on the Lorentz curve, right? So what this curve means. So this actually is the basis of calculating the Gini index. So now this curve describes basically the level of equality or inequality. So let's just look at the x-axis. So x-axis represents the percent of families, right? The percentage of families. And then the y-axis represents the percentage of income. So in the ideal situation, we would like to distribute the wealth sort of like equally, right? So for example, at this point, when x equals to 0.2, means that we want to distribute 20%. Okay, so this is 0.2 as well. And that is just y equals to x. So we want to distribute 20% of the income of the wealth to 20% of families, and similarly for other points on this line. So if we are at this line, then we are actually seeing that the society is equal, right? So this is called absolute equality. But that's not the reality. So in reality, we, for example, have for the same percentage of families, right? So for the same percentage of families, we have sort of the poor income, the low income families that's actually drawing the line down. So this is drawn down to these points, right? So meaning that their income actually gets distributed to the higher income families, right? That's why the percentage of income gets drawn down and is to a lower point. And you see that this curve is actually increasing a bit slow. Right? It's starting a bit slow because the income is being redistributed to this portion. So this portion is actually growing very fast, right? And that's because of the income redistribution. So that's we have another curve that's actually representing the reality. And now, how is this curve being drawn? You can just have all the income, the family incomes, and then calculates each point, and then they draw this curve. So, for example, under 21,000, we have this is a percentage we have, right? So this percentage is the cumulative percentage, right? So, and then for each tier, we just calculate the percentage, and then we have the points, and then for other points, we can just draw a curve. Okay, so now the question is, how do we sort of measure the level of inequality in a society? Before we go to the Gini index, I just want to mention that this curve, right? So this horizontal curve represents the absolute inequality. So why is that case? Because now for different percentage of families, the percentage of income is just zero, right? So it's just zero. And then suddenly at this last point, we jump to suddenly to one, right? Why? Because all the wealth is just being aggregated into one family, and then when we account for this family, then we suddenly jump to the one. So that's an extreme case. Okay, so Gini index. Now, Gini index essentially measures is related to the area between these two curves, right? So this is something we covered earlier. So how to calculate the area between these two curves, right? So so this is the area between these two curves, and then this again multiplied by 2. Right? Why are we doing multiplied by 2? Because this half is just half of area, and if we multiply by 2, then we have the total area, right? So there is 1. So so meaning that the maximum value is 1, and the minimum is 0. So Gini index is a number that's always between 0 and 1. And when it's 1, right? When it's 1 means that we're actually calculating 1 is 2 times 0.5. So this area is 0.5, right? So if we do the calculations, can be 0.5. And this represents, so when Gini index is 1, this represents absolute inequality, right? So absolute inequality. And if it's 0, it represents absolute equality. That's when the f of x sort of overlap with x, right? So basically we're calculating the distance, right? The difference of these two functions, and then integrated along all the points, all the different points on this interval, right? With respect to x. So this is what we have, and basically this is a sort of a unified single metric to measure a society in terms of the wealth distribution and inequality, right? Okay, so let's look at exercise. So in this case, we have f of x equals to x to the power of 2.6 in 2017. And then the target predict. So that's prediction that's by 2030 this function would be x to the power of 1.8. So so basically we need to find the income concentration of each curve. So just plug in this, do its evaluation twice, and then compare the results. So the comparison means that we're going to integrate either the Gini index is increasing or decreasing, right? And then based on that, to do an interpretation in terms of are we getting better in terms of equality of wealth. So that's how we can calculate and interpret results. Okay, so a relevant concept based on the area under the curve is that we can first calculate the area under the curve, right? And then divide by the sort of the range of the x-axis. And then we can get the average value of a continuous function. So so the simplest case would be just a triangle, right? So triangle, we know that, so we can calculate area under the curve, and then divide by the length. This is from A to B, and then we have the height. So height means the so on average how tall it is. But of course, this is a rectangle that's uniformly distributed. So it's just itself is the same value. But when the curve becomes when this is a curve, right? When it's a curve, then what you want to do is actually to calculate the area under the curve. So this is the area under the curve, and then apply the same method to divide by the length. You can get the height. Essentially, want to say what is the average height or each value for this function. All right, so it's just a related concept. Next will be probability density function. So this is again a widely used function concept especially in statistics. So what is the probability density function? So this again is a function, right? So it's function y equals to x, and its function is always bigger than or equal to 0 because it indicates the probability of something happening, right? The probability cannot be less than 0. It can only be bigger than 0 or just 0. Okay. So what that means is that we have this this x. This is f of x. So f of x essentially represents for a given x, right? What is the probability that this happens? So when x equals to, for example, a, now we have what is the probability when x equals a, right? And then we have different points and different probability. So when we are asked, for example, what is the when we give an interval c to d, right? So what is the probability within this interval? So x within to be within this interval. Then we can use the tool of integration. For example, this is c, this is d. Then we can just take the area under the curve within this range to get the probability. This is the probability within the range, within the interval. So and of course, when we look at the whole interval, then it needs to be exactly 1 because the probability of all the different outcomes should sum to 1. All right. So again, this is the how we can calculate the probability for something that's actually within the range, and we take all the ranges, all the like infinity, close infinity, then should be 1. And we should highlight that x now is a continuous variable. So it's continuous means that the example could be the salary, the income, right? And then we have different salaries with its probability. But that salary itself is a continuous variable. So it's there's infinite infinitely manning the values of salary. Okay, so and there's one special type of probability density function called the normal function or normal curve, right? So its form is like this one. So basically, we can still plug in x, get a probability. And then the calculation is actually looking like this, and it involves two sort of additional parameters. One is mu, one is sigma. So we have sigma here. So these are parameters that govern the shape, right? That determine the shape of the curve. So mu itself stands for the center of the normal function, right? So center, and then the sigma represents how wide the function is, the curve is. So this is measuring the width, right? The width of the curve. So when it comes to a standard normal distribution, we have mu equals to 0, right, center around 0, and then the standard deviation equals to 1. That's just a special type of PDF, probability density function, which is quite widely used. Okay, so let's continue. Here we want to look at continuous income stream. So let's look at what is income stream and what it means to there are different ways to interpret the income stream. So let's imagine a scenario where we have $2,000, right? So $2,000 we save it every every month, sorry, every year. So this is 2,000 per year. Right, this is the amount of money we save. I want to save it, save for 10 years, right? 10 years. So each year we do is we save 2,000, and we save it for 10 years, and then the total savings will just be 10 times 2,000 equals 20,000. So this is how we calculate. Again, this represents the cumulative or wealth we have once we save it for 10 years. And additionally, we can look at the problem in another perspective. So the perspective that we represent the savings, the income, the continuous stream, right? This is our income, and it's going to be always 2,000, 2,000. And then this is the years, the number of years, right? So for example, for year one, we save 2,000. Year two, we save 2,000, etc. All the way to year 10, right? So now the question asks, what is the amount of money? What's the total amount that we save in 10 years? So this is something you can calculate. So it's just the area under the curve, which represents the total wealth, right? The total wealth accumulates across this range. So in the notation wise, we actually want to integrate. This is the line, the curve, one thing, instruction the t time. So dt, and then we are going from 0 to 10. This is another equivalent expression, and so we can just move 2,000 outside, do the calculation. So this is going to be the 2,000 times t, right? Because the constant is 1 is the 1. If we can integrate it, it's going to be t. And then we need to denote that we are taking it from 0 to 10. So, and then the result is going to be multiply 10, and again 20,000. So this is the similar interpretation. So there's two different perspectives. All right. And again, the total income it can be calculated as either under the curve based on the single point. So this is the curve that represents the single point income. And if we plot it here, this is going to be a string income, right? That's like for example, our salary per month, and we have different salaries per month. Sometimes we change jobs, sometimes have additional bonus, etc. And then it's total income represents the accumulated wealth, the total income, the compensation we have. Right. So this is again what it means. So the x-axis, the rate of change of the income, with the online interpretation, basically represents for each single point in time what is the income we have, and then it describes how fast something changes. So this is the curve, and I want to know that what is the total income. So it's basically in the first 5 years. So we basically can just plug in the formula for 5 years, and then when it's the integral, once we calculate this integral, and find out what's the total income. So that's just another application related to the total income and the single point income, which describes how fast it changes. And relatedly, we have the future value of a continuous income stream. So what this means? It means that this is our income example. Okay, for each point, and we have each point on t, we have the income alpha t. This is the salary we receive at a particular time point t, and our endpoint is t, uppercase t. So when we have the condition that the income is continuously invested at rate r and compounded continuously, right? So it means that this income itself is going to get compounded continuously until this endpoint. So in the middle we have alpha t minus the lower t. This is the time period, it's the duration we're going to save. For example, in the bank, and then the money will grow continuously compounded, right? So for this money, to do content components, so at this endpoint, these amounts will will grow into the amounts using the continuous compounding formula. This is R, and then multiplied by the duration. So this is the money we'll get. And this is just for single point FT. We need to do this for all the different points. So basically, we have a new function here. We want to integrate and then to calculate total income. This is the future value of continuous income stream. All right. So lastly, let's talk about the demand supply curve. So this curve represents for each, for example, for this point, we have a price, we have quantity. So for example, customer will buy this amount of products given the price here. Right? So this is the demand curve. Okay, so it's not worse because as price gets more expensive, of course, less people will buy. Right now, what's the consumer surplus? Sense is that for given point, for example, if you look at this point, now this is okay, we're selling for this utility and we're selling at this price. So this price may be not too expensive for some people, right? Because they are more wealthy and they still buying this product at this price. So imagine the price increases. Right? So imagine the price increases. Then they will actually okay, so they actually are able to buy the product. For example, we'll look at another point here. So originally, this is our price P1, which is the active price, right? So originally we can't afford to buy at the active price, so they are positioned here. But now the product price is here, right? So it means that we actually save this amount of money, right? Just by purchasing a product that they are able to buy, and now it's sort of like within their purchasing power. So this amount essentially represents all those consumer surplus, so the money saved by the consumers when they purchase something. So this is something that now is, of course, even if the product become more expensive, they will still buy it. But so this actually is the range they saved. If we consider all the different cases, then so this is the surplus for this type of customer, and it's surplus. If we add all these surpluses together, then we have the area of this the green area, and this represents the consumer's surplus. So this is the money saved by the consumers. Similarly, we have the money saved by the producers. So again, some interpretation. This is the money saved by the producers, and just represent its area. Again, the in between the price P bar and the curve, the supply curve we have. All right. So and lastly, we have the equilibrium price. Again, it can be identified by equating the demand curve and the supply curve to show for the price and the corresponding quantity, and that from there we can calculate what is the consumer's surplus and what is the producer's surplus. Right. So that's it for this video, and thanks for watching.